Hi there everyone, and I just want to welcome you right here for this first lesson in the first chapter of mathematics. Alright, and my name is Joel, your tutor for this lesson. Alright guys, so this first chapter is called number bases. So what are actually number bases? To begin with, let's take a look at a few colorful pictures. Alright, so what do you guys see right here? Alright, both pictures, as you can see, consist of many figures, right? And those numbers there, you can see, are actually all the numbers that we use in our everyday life. Alright, so what about this picture? Same, right? So all we have to know right now is numbers have been a part of our lives, alright, since we were very small, right? We have been learning how to read the clock, alright, how to go and buy things and stuff, alright? So remember that numbers play a very essential role in our everyday lives. Okay, so back to the title of this chapter, number bases. We are going to actually look, alright, at the number base that we have been using since we were small, and also the introduction of 3 more number bases. So now let's take a look at the introduction to number bases. Numbers that we deal with every day belong to the decimal system. In the decimal system that uses a base of 10, we count from 0 to 9, then resetting the next number to 0 and carrying 1 into the next column, becoming 10. This is probably a result of having 10 fingers. Alright, so have you guys ever wondered, alright, the origin of the number system that we have been using? We have 10 digits, right? From 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So altogether we have 10. Alright, so this is probably so because we have 10 fingers, and the earliest mathematicians developed it because humans have 10 fingers. Alright, so now let's take a look at another possible case. What about if we were looking at an alien from another planet? For an alien with 8 fingers, probably base 8 instead of base 10 would be used. Numbers in base 8 are known as octal numbers. Alright, so just imagine, okay, in the planet Mars, for example, if an alien that has only 8 fingers, then what are the digits, alright, that he can actually count with his fingers? Alright, he would only be able to count, alright, less, alright, than what humans can count. Computers, on the other hand, work using electronic circuits which can only be switched to be on or off. Alright, so the computers, use circuits, which are made, of electronic circuits, off and on in an instant. When a key is pressed, the keyboard characters and numbers have to be converted into a sequence of ones and zeros so that the computer can open or close its electronic switches in order to process the data. Because only 2 possible symbols can be used, this is called a binary system. This system works to a base of 2. Numbers working to a base of 5 are also used. So, in Chapter 1, we are going to learn the mathematical operations of different numbers in base 2, base 8, base 5. Alright, so we are very used to numbers in base 10. Okay, just remember, base 10 simply means, the number base has 10 digits from 0 to 9. But that is not the only number base, because as we have seen, just moments earlier, there are a lot of applications, that uses numbers in base 2. Remember that? A lot in computers, and base 8 as well. So we are actually going to take a deeper look at these 3 bases. What are they again? Base 2, base 8, and base 5. Now let's take a look closely and compare the 4 number bases. Alright, base 10. The digits in base 10 are 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Alright, base 10 simply means 10 digits in the number base. Okay, an example, 55. Okay, we just pick any number that we have been using in base 10. And as you can see, we actually write a small little 10. Okay, or a subscript 10, alright, at the bottom, alright, of the number to indicate that we are in base 10. Alright, base 2, as you can guess, it has only 2 digits, 0 and 1. So an example would be the number 111011. Okay, and we write a small little 2 or the subscript 2 to indicate that we are in base 2. Base 8, digits 0, 1, 2, 3, 4, 5, 6, 7. So there are 8 digits, okay, and don't forget we always start from 0. Example, 6, 7 in base 8. Alright, base 5, the last base consists of 5 digits, 0, 1, 2, 3, 4. Okay, an example of a number in base 5 would be 210. Alright, so now we have been introduced, alright, to 3 other bases. Okay, so we're going to actually look at the first task right now, which is writing numbers in base 2, 8, and 5. Alright, now let's take a look at a few points right now. A number in base 10 can be converted into base 2, 8, and 5. Steps to convert a number in base 10 to a number in base 2, 8, and 5 are as follows. Step 1. Perform repeated division until the quotient is 0. Step 2. Write the number in the new base by referring to the remainders from bottom to the top. Okay, so what we're going to do right now is basically this, alright? So take any number in base 10. Okay, base 10, alright, means our common base that we have been using. Any number, just pick any number. Okay, so if you have that number right now, you can actually convert it to a number in base 2, 8, or 5. Okay, because when we convert, alright, this number to another base, actually its value stays the same. But because every base is represented by its own respective set of digits, then it will be expressed differently. Okay, so now let's take a look at this example. Convert 17 in base 10 as numbers in base 1, 2, 2, 8, 3, 5. Alright, the method used in converting numbers from base 10 into base 2, 8, and 5 is called Quotient Method. Alright, now let me just bring you to the board right now and let us convert 17 in base 10, alright, to a number in the 3 other bases. Now let's go. Alright, so now we have, alright, our number in base 10, which is 17. Okay, so it is a normal number, and don't forget that the subscript there indicates which base we are in. Okay, now suppose that we want to convert it to base 2 first. Okay, so now let's convert it to base 2. Okay, so I'm just going to do it right here. Okay, we're going to change it into base 2. Alright, so how do we do it? Okay, remember we are going to use the quotient method, okay, or repeated division, because we are going to divide this number, alright, repeatedly, alright, with 2. So if I want to convert it to base 2, I got to take the number which I want to convert, 17, and divide it repeatedly with 2, okay, because we want to convert it to base 2. Okay, so now how do we do this division? Very simple, okay? So now can you tell me what number multiplied with 2 will give me the nearest to 17? It is 8, right? Because 8 multiplied with 2 gives you 16, but you don't write down the 16. Okay, so you just keep it in your mind. Alright, so 16 and 17, notice that there is a remainder of 1, right? So you write the remainder right here. Okay, again, what number multiplied with 2 gives you nearest to 17, which is 8. Okay, so 8 by 2 gives you 16, and 17 there is a remainder of 1, so you write it here. Okay, so 8, okay, divide it again, alright, with 2. Okay, so now we have a nice number. 4 multiplied, alright, with 2 gives me 8. Alright, and we have no remainder, so write it right here. Okay, so apply and repeat the same process. Now, same thing, all the way. Okay, so now divide it again with 2. Okay, so do we have a nice number? Yes. Okay, 2 multiplied with 2 gives me 4, and there is no remainder. Okay, go on, okay, until we can stop at a point. Okay, so divide with 2, yes. Again, 1 multiplied with 2 gives me 2. So 0 remainder. Alright, so now what happens is this. Okay, when the number inside here is smaller than 2, okay, we stop, alright, the division process, alright, by putting 0 right now. Because 0 multiplied with 2 gives me 0, and the difference between 0 and 1 will give me a remainder of 1. Okay, so we have to divide repeatedly until we arrive at 0. And this is achieved, okay, when the number inside here is smaller than the number outside. Okay, so we have done repeated division. All we have to do now is remember to read the remainders and join them together from bottom to top. Okay, so it means that 17, alright, in base 10 is equal to 1, 0, 0, 0, 1 in base 2. Alright, now let's convert 17 in base 10 to base 8. Okay, so now same thing, we're going to use the quotient method or repeated division. So let us do it right here. Okay, so now let us change, alright, or convert it to base 8. Okay, so guess what? Can you guess, alright, what we're going to do? Based on what we have just seen earlier, same thing. Okay, so take the number that you want to convert, okay, which is 17 in base 10, and since we want to, alright, convert it to base 8, we're gonna divide, alright, repeatedly with 8. Okay, so now can you tell me what number multiplied with 8 gives me nearest to 17? Because we can't get exactly 17, right? There will be a remainder. Okay, so it will be 2 times 8, right? It gives me 16. So 2 multiplied by 8 gives me 16, but again, don't write at 16 anywhere. Just keep it in your mind and find out the difference between 16 and 17. The remainder is 1. Okay, so divide again, remember, until you come to 0. And when is it? It happens right now, because 2 is smaller than 8 already. We finish the division process by putting 0. So 0 times 8 gives you 0, and 0 and 2 gives us a remainder of 2. Okay, so how do we read the number? In base 8, we have already done the conversion, bottoms up. Okay, and now what do we have here? So 17 in base 10 is equivalent to 2, 1 in base 8. Alright, so one more conversion to do to base 5. Remember guys, alright, the method is always the same. Repeated division. Okay, so now let's take a look. Same number, okay? So we are going to actually convert it to base 5 right now. Okay, so base 5. Okay, so base 5, don't forget, it only consists of 5 digits. Okay, so the same number. Alright, if I want to change it to base 5, I'm going to divide it repeatedly with 5. Okay, same process. Now, can you just help me along the way? Alright, what multiplied with 5 gives me nearest to 17? So just think, 3 multiplied by 5 gives me 15, right? It's the nearest already. Don't exceed. 4 multiplied by 5 gives me 20, so it can't go beyond 17. So it will be 3 multiplied by 5, and it will give me 15. So just think for a second. The difference between 15 and 17 gives me a remainder of 2. Okay, and then go on, divide with 5 again. Alright, do you stop here? Yes, because the number inside here is actually smaller than the outside. Then you stop by finishing off with 0. 0 times 5, 0, and then 0 and 3. The difference or the remainder is 3, so it will be 3. Okay, now remember, don't read it, alright, from top to the bottom. Remember, read it like how a bat would read it, okay? Alright, from down to up, okay? And lastly, write down, what is it? Okay, so 17 in base 10 will be equivalent to 3, 2 in base 5. So guys, we have seen that a number in base 10 can be converted to a number in the 3 other bases. Okay, so remember the technique, okay, which is called the quotient method or repeated division. Now, let's move on to the next part, alright, of this lesson. Stating the value of a digit of a number in base 2, 8, and 5. Alright, how do we get the value of a digit? The value of a digit is equals to the digit multiplied by the place value of the digit. Okay, so just think for a second. The value of a digit is actually the digit multiplied by its place value. Okay, now let's take a look at this example right now, starting with base 10, alright, to give us a clear understanding. State the value of each of the digits in the following numbers. Okay, so it's the value of each digit. 1 in 5269 in base 10, 2 in 1011 in base 2, 3, 63457 in base 8, and 4, 3241 in base 5. Alright, now let's take a look at the first number, which is a common number, alright, in a common base. And why do I say common? Because this base 10, alright, the numbers we use, alright, are the numbers we use in our everyday life. So in 5269 in base 10, okay, what are the values of each of the digits that you see right there? 5, 2, 6, and 9. Okay, why do we call it 5269? Okay, now what are we going to do right here is prepare a table consisting of 3 rows. The first row is for the place value. The second row is for the number. And the third row is for the value of the digit. Alright, so since we have 4 digits, alright, the place value would be, alright, if I start from my right, 10 to the power of 0, because the first digit has the power of 0. 10 to the power of 1. Second digit has the power of 1. 10 to the power of 2. Third digit has the power of 2. And 10 to the power of 3 because it increases by 1. Okay, so the place value of each digit in each position is dependent, okay, on the place value in that particular position. Okay, so starting from the right, okay, if it is base 10, it will be 10 to the power of 0, and then it moves inward to the left, 10 to the power of 1, 10 to the power of 2, and so on. Okay, so the numbers, alright, are there, just place them, 5, 2, 6, 9. So the value of the digit would be the number multiplied with the place value. Okay, so for 5, it will be 5 times 10 to the power of 3, 5,000. Okay, for 2, it will be 2 times 10 to the power of 2, which is 200. Alright, for 6, it will be 6 times 10 to the power of 1, which is 60. And for 9, it will be 9 times 10 to the power of 0, which is 9. So the value of each digit there, alright, is, as you can see, 5,260 and 9. Okay, so that is very simple because base 10, we have been learning that base, alright, since young. Okay, but what about a number in base 2? 1011. Same thing. Place value. Okay, now watch. Alright, so as we start from the right, the place value of, alright, the number on the right will be 2 power of 0. Starts with that. Because since the number is in base 2, the place value of this digit is 2 to the power of 0. And then guess what? As it moves, alright, toward the left, it will be 2 power of 1, alright, 2 power of 2, 2 power of 3. Okay, so the numbers are 1011, and the value of each digit would be, alright, the product of the digit and its place value. Alright, so for the first digit, starting from the left, 1 times 2 to the power of 3. Okay, so the value would be 8. Alright, 0 times 2 power of 2, value 0. 1 times 2 power of 1. Okay, so that one will give me a value of 2. And the last one, alright, which is the one on the right, alright, the value of the digit is 1 times 2 power of 0. So it gives me a value of 1. And what about 3? A number in base 8. 63457. Okay, now I will let you just examine this table. Alright, because you would probably know the pattern right now. So in base 8, the place value, alright, starting alright from the first alright digit on the right, okay, that particular position holds a value of 8 to the power of 0, and then 8 to the power of 1, 8 to the power of 2, 8 to the power of 3, 8 to the power of 4. So remember, in base 8, so it's 8 to the power of 0. Okay, so the first alright position on the right always starts with the power of 0. Okay, and as the numbers are arranged there, alright, you can find the value of each digit by multiplying alright the number with its place value. Alright, and lastly, a number in base 5, 3, 2, 4, 1, same thing goes. Okay, so I want you guys to just take a look at the place value. Since we are in base 5, starting from the position on the right, it will have a value, alright, of 5 to the power of 0, okay, the place value, 5 power of 1, 5 power of 2, and 5 power of 3. So the value of each digit would be the product of the digit and its place value. Okay, for example, 3, the value of that digit, how much worth is it? It's actually just 3 multiplied by 5 to the power of 3. Alright, now let's take a look at, alright, an objective question, alright, relating to this. Alright, and I want you guys to try it. What is the value of the digit 4 in base 10 in the number 2, 4, 5, 7, which is in base 8? A, 400, B, 256, C, 40, D, 32. Okay, so I'll just give you guys a while to try out this question. Alright, so now let's take a look at this number in base 8 again. 2, 4, 5, 7. Okay, so notice we are in base 8 mode right now. Okay, so what we want is just the value of the digit 4. Okay, and most times, alright, in a questions like this, alright, a particular digit, alright, will be asked and it will be underlined. So we just want the value of the digit 4. How much will it be worth? Okay, so one thing to note, okay, if we are getting, alright, the value of a digit, okay, we are actually getting its value worth in base 10. Okay, let me just show you what to do right now. Okay, so we have known that to get the value of this digit 4 is very simple. We just have to take the digit 4, because remember, the place value is the digit multiplied by its place value. Okay, what is the place value, alright, of this position for a number in base 8? So remember, as we have seen in the table just now, it is 8 to the power of, okay, we start from the right, 8 to the power of 0, 8 to the power of 1, 8 to the power of 2. Alright, so this is what we want. So it will be 8 to the power of 2. Okay, so it will be 4 multiplied, alright, with 64, which gives us 256. Okay, so the value of the digit 4 in base 8 right here in this number is actually 256 in base 10. Alright, so the answer is B. Okay, so now with what we have learned, alright, regarding the number bases, alright, especially the bases 2, 8 and 5, and of course, alright, the base 10, we can move on to writing numbers in base 2, 8 and 5 in expanded notation. A few points now to take note, alright? So the knowledge about expanded notation has been known for quite some time. For example, okay, a number in base 10. So it means that we have actually written 75,341 as a sum of the product of every digit and its place value. Okay, so now in a higher level, we write the same number as 7 multiplied by 10 to the power of 4, plus 5 multiplied by 10 to the power of 3, plus 3 multiplied by 10 to the power of 2, plus 4 multiplied by 10 to the power of 1, plus 1 multiplied by 10 to the power of 0. So take a look at the power in expanded notation of each digit from right to left. So can you identify its pattern? It slowly increases from 0 to 1, 2, and so on. So similar patterns of expanded notation can be written for numbers in base 2, 8, and 5. Writing a number in expanded notation simply means writing that number as the sum of the product of every digit and its place value. Alright, so for example, write 7,314 in base 10 in expanded notation. Alright, so very simple. We know that there are 4 digits, hence 4 place values. Remember that? Alright, 10 to the power of 0, 10 to the power of 1, 10 to the power of 2, 10 to the power of 3, from the right to the left. Alright, and the numbers. Alright, so expanded notation will be as follows. 7314 in base 10 is equals to 7 times 10 to the power of 3, plus 3 times 10 to the power of 2, plus 1 times 10 to the power of 1, plus 4 times 10 to the power of 0. Alright, so using the same pattern, you can write numbers in base 2, 8 and 5 in expanded notation. Okay, now let's take a look at one more example. Write each of the following numbers in expanded notation. A. 10111 in base 2. B. 635 in base 8. C. 3243 in base 5. Alright, now let's go over to the board and do this one. Alright, let's write this first number in expanded notation. Okay, so remember that expanded notation is simply writing this number as the sum, alright, of the product of every digit multiplied by its place value. Alright, so let's start with the digit here. Alright, so what would it be? It is 1, right? Multiplied with the place value. What is the place value of this one? Simple. Remember, since we are in base 2, it will be 2 to the power of, okay, 0, 1, 2, 3, 4. So it will be 1 multiplied by 2 to the power of 4. Alright, okay, what about go to the next digit, which is 0. So you can see the pattern already. 0 times 2 to the power of 3, okay, and then this next one will be times 2 to the power of 2. Alright, next one, alright, would be 1 times 2 to the power of 1, and lastly, this one would be 1 times 2 to the power of 0. So that's it, okay? You have managed to write this number in expanded notation, okay? So you remember the word expanded notation. Okay, now let's go over to the next number. Alright, so 635 in base 8. Okay, so base 8, same. Apply the same pattern. Okay, so 635 in base 8. Okay, let's start with the 6. Okay, so expanded notation means 6, alright, multiplied with its place value, it would be 8 to the power of 0, 1, 2. Alright, added with 3 multiplied, alright, by 8 to the power of 1, plus 5 multiplied by 8 to the power of 0. Okay, so once you've gotten the pattern, it would be very simple. Now, what about the next one? Alright, so we have a number in base 5. Okay, so let's write it in expanded notation. Okay, so start with 3. Okay, so what will it be? 3 times 5 to the power of, okay, remember the place value always starts from 0 at this position, 1, 2, 3. Alright, so once you have gotten this, the next one will be less, so it's 2 times 5 to the power of 2, alright, plus 4 times 5 to the power of 1, alright, plus 3 times 5 to the power of 0. Alright, so this is the expanded notation for this number. Alright guys, so we have learned pretty much, right, about number bases in this first lesson. Now let's take a look back at what we have learned. Alright, so we have learned the 3 types of number bases: base 2, 8 and 5. We have also learned that base 2 consists of digits 0 and 1 only. Base 8 consists of digits 0, 1, 2, 3, 4, 5, 6, 7 only. Base 5 consists of digits 0, 1, 2, 3, 4 only. The value of a digit is equals to the digit multiplied by its place value. For example, 1001 in base 2 has the value of 1 times 2 to the power of 3, which is equals to 8. And lastly, numbers in base 2, 8 and 5 can be written in expanded notation. For example, 374 in base 8 is equals to 3 times 8 to the power of 2 plus 7 times 8 to the power of 1 plus 4 times 8 to the power of 0. Alright guys, so that's all for this lesson. We'll be looking at more, alright, involving number bases in the next lesson as well. Alright, so I'll see you guys then. Goodbye.